the cost of the operational of the solution. But in case of fire, we need to extract the smoke more or less in the middle of the tunnel. So there is a huge smoke extraction system. It's a big cavern inside with a small shaft to outside. So this is the back of the smoke extraction. The fans have 3 meters of the diameter. I told you that there are cross connections at every 200 meters. Of course, we need to protect them, and there is a specific system to pressurization to create overpressure in the cross connections in order to avoid the smoke to get in these cross connections. And here I start. Why we decided to install so many things in the tunnel? So first of all, we need to monitor if those doors are used or not. So this pressurization system keeps shut it down. There is no need to keep the tunnel, the cross connection pressurized if there is nobody there. So basically, you have sensors in the doors and also infrared motion detectors to detect if there is someone there. If someone opens the door, then we start the system. So it's a bit complex in terms of automation, but this can save a lot of money during the whole life cycle of the tunnel. We install also in the tunnel a lot of sensors, as was discussed this morning as well. We need to monitor the air quality. And this is in Brazil made by the law, monitoring the opacimeter of the particles in the air by the opacimeter, the NO2 and CO. So we have these 3 sensors along the tunnels, and also anemometers to check the airspeed. So also there is a loudspeaker system, of course, and this loudspeaker system needs to be laudable for the people. So there is important also to have a noise sensor in order to control the volume of this system. We installed luximeters along the tunnels, and it's interesting because we need to make sure how much light we are giving to the drivers. And normally during the lighting design, we assume that a part of the light is lost by the dirt in the luminaires or by the aging of the luminaires. But if you have no control of it, since the day 0, we are giving more light than is needed. And in my opinion, it's too much light. If you compare how much light you give inside the tunnel and in a normal highway, the tunnels are over-illuminated in general. And this represents the biggest part of electric bill. So the ventilation sensors more in detail. So it's a system that is combined the opacimeter, NO2 and CO, and anemometers. So what are the goals of the too many sensors in the tunnels? The air sensors, the main goal is to get the most accurate information regarding the air quality in the tunnel. So if we have the right information from the tunnel, then we can take the right choices. So it's impossible to keep those fans running if they are not necessary. So in order to make sure that people are not subjected to pollutants that are not allowed, we need to make sure that to meet the air quality. And also during the emergencies, it's important to keep control of the longitudinal velocity of the air, specifically because in tunnel 3/4 that we have this smoke extraction shaft that requires a bit of automation behind it. Otherwise, all the tunnels are longitudinal, that it's easy, just press the button, turn on all the jet fans in the correct direction, and that's it. In terms of lighting, I'll show you later why we decided to install so many lighting sensors. So we have illuminance meters on the walls. Those illuminance meters, the aim is to make sure how much light we are having from the light sources, not giving to the drivers itself. So they are on the walls. It's a small box on the walls. We have illuminance meters at every 100 meters. And of course, in order to control the light and the adaptation light in the tunnel entrance, there are luminance meters We have two luminance meters on each portal in the two different distance used by in two different scenarios. The goals of those meters are to get information, the luminance meter, from the external light in order to dynamically adopt the light. So there is no reason to illuminate the tunnel entrance as have a sun during the midday, during the summer, if there is very early in the morning or very late in the afternoon, if there are no sunlight in the tunnel portal. And the luminance meters along the tunnel is to control the dirty on the luminaires. In this case, we can give more power to the luminaires since we planning a cleaning process in the tunnels. So this is a general arrangement of the tunnels. There are also signals and communication. There are VMSs along the tunnels. Of course, CCTV and instant detections. And the firefight system. So we decided there, based on Brazilian regulation, to install only the basic firefighting equipment. It means we have at every 60 meters this emergency point where it's available water, a fire extinguisher, and a telephone to communicate to the control room. Important thing was decided with the fire services that this system must deliver the same amount of water, pressure, and flow rate they have from their own fire tender. So it's quite a big system. And of course, to protect evacuation, we have the loudspeakers to guide the people there. This was a requirement by a specific Brazilian law that says we have to design the tunnels for deaf people, blind people, disabled people. So this was a requirement by the state. And of course, the cross connects are protected by fireproof doors. So the water reservoir, there are 240 cubic meters, and the pump room that is located in the highest part of the tunnel. So this was a briefly presentation about the tunnels, but what are the main costs? During the design, the customer was asking us, because this is a PPP project, it means the government is paying with public money by the construction, because the infrastructure belongs to the state. But the private company, with money collected by toll, it's to pay the electric bills, maintenance, personnel, refurbishment, etc. So it was a huge question about how much does it cost during the construction phase. And we did a lot of studies at that time, and we decided a few things. First thing is that electricity is our biggest cost in this project. And we took two interesting decisions. First decision was we only buy electricity from the grid in order to keep a normal operation running. It means in case of emergency, we generate our own energy based in diesel generators because we don't have emergencies every day. So there is no reason to buy electricity from the grid 365 days a year if there is emergency once or twice a year. So there are a stronger diesel generator system in the tunnel itself, in the tunnel portals, that can generate more than enough electricity to deal with any kind of emergency. Only with that, we save something about €1 million per year in electric costs. And also, in terms of operational safety, they decided to keep the number of staff, the personnel and the staff, very low. So they decided for a very high level of automation. On the other hand, this requires a very high level of maintenance, so be careful with that. But the use of artificial intelligence and automatic incident detection in different levels, and also equipments to do tasks in the tunnel. So in case of a tunnel closure, they have a lot of equipment that can close the highway and put message, so they don't need to send people there because they have no people, basically. Everything is done by the control room. Of course, cost of maintenance and equipment replacement, they are in third and the fourth place. Just to give you an idea about the electricity problem, in terms of installed power, the ventilation corresponds to 87.85% of the total power installed in the tunnel. But as Professor Peter Sturm told us in the morning, we normally do not use if this tunnel is longitudinal ventilation, unidirectional traffic. So for this reason, we decided to not buy this amount of electricity from the grid. The tunnel light corresponds to 11.27% of the installed power, but corresponds to 95% of the electric bill. So for this reason, we decided to be very detailed in terms of monitoring of the light and to control the light, of course. Why we decide that? During the studies for that, during the design, we have computed the amount of fresh air required for the tunnel operation. And as the ventilation, as you can see here, is the biggest power installed in the tunnels, we looked into details in that figures. And we find out that for few tunnels, as I show you here, after 20 kilometers per hour, if the traffic is moving after than 20 kilometers per hour, the natural ventilation generated by the car movement and the buses and trucks, it's enough to generate a flow that it's more than sufficient to dilute all the pollutants inside the tunnel. It means it's ventilation for free. But important, this is only valid if the tunnel is unidirectional and if there is if you know the traffic. If you don't know the traffic, it's difficult, or if you don't know the emissions, it's difficult. But Brazil, there is a quite a good emission standards, and we could compute that. It means we have to avoid at any cost traffic flowing lower than 20 kilometers per hour. If this is true, we don't need to start the ventilation, and of course, we don't need to buy electricity or to turn on the diesel generator. So for the 4 tunnels, as you can see, the length of the tunnels are a bit different, but more or less at every more than 20 kilometers per hour, if the traffic is moving over that speed, it's safe. The natural ventilation generated by the cars are sufficient to the normal operation. So, as I told you, we decided in this project to install the electrical rooms just in the portals, and inside the electrical rooms there are the diesel generators. As I commented with you also about operational measures, in case of tunnel closure, this is a tunnel portal, it's a tunnel 1. Tunnel normally it's working like this, it's open, you have a green light, and the VMS is showing some normal message. But in case of emergency, or if you need to stop traffic for any reason, we do it directly from the control room, and this is the scenario the drivers can see in the tunnel. So there is no need to send personnel there. Yeah. So lighting, as I told you, is our biggest part of the electric bill. It means we have to be very detailed in control of it. I know that Pierre has a good presentation about this subject as well. It's an important subject. The committee decided to investigate it also for the next cycle. So what we did there, that it's already running. So during the daytime, the light levels are more or less controlled by the outside lighting levels. Also about the weather conditions. If the pavement is wet, it means we need more distance to stop cars, and we need to illuminate a bit more. But if the pavement is dry, there is no need to illuminate it so much tunnel entrance. Traffic volume outside and the average traffic speed. Okay, I'm finished here. And during the night time, we control it based on traffic volume, average traffic speed, and it's important. During the nights, the traffic is very low, so we basically shut down the lighting system and use just part of it. Okay, thank you, and I'll be available for questions in the next, at the end of the session. Thank you.
Thank you, Ricardo, for a very nice presentation. Now our second presenter is by René List. He will be presenting the way to sustainable and efficient road tunnel operation. I just forgot to inform that the first presenter, Mr. Ricardo, is a member of TC 4.4 committee. All the 3 presenters today are member of TC 4.4 pairs committee, including René List.
So yes, microphone is working. Yes, hello everybody. My name is René List. I'm working for ASFINAG in Austria. My role is I'm the chief engineer for electromechanical infrastructures for the highway network in Austria. And ASFINAG is the road operator with a lot of different jobs to do. And I just want to introduce also a little bit ASFINAG, just to give you an idea. So what we do is we do operation, we do continuous maintenance and upgrading of our highways and highway network. We do the expansion, so the construction of new routes. We do toll collection and also the financing. So we are a full traffic highway operator, and we are structured like in a holding company group structure, and we have, as you can see, 7 different companies. And the main the main companies are the operating companies, where you can see these snow removal trucks. Then we have the tolling, and we have the ASFINAG Baumanagement, which means the construction company. And I'm working for the construction company. These are the key figures to give you an idea. ASFINAG, we are operating 166 road tunnels on the highways. These tunnels are managed by 9 traffic management centers across Austria. We have 42 motorway operation centers, and our road network is 2,250 kilometers, and all this work is done by around 3,000 employees. The driven kilometers per year are 26 billion kilometers. So our sustainability measures are not only related to energy and operation savings in that area. We are also doing something like green bridges for the animals, wildlife fences. We are doing material recycling from the construction. We're installing noise barriers. And last but not least, we are installing a lot of photovoltaic system, solar panels to generate now power and supply this for operation centers and also for our customers and our infrastructures. What are the strategic goals of ASFINAG in that area now when we look at the energy part? So the first goal is to reduce the energy consumption by minus 20% till 2030. Then we want to cover our own electricity needs independently on balance. That means the total energy volume we need has to be produced by the road infrastructure, same till 2030. And therefore, we need to install around 100 megawatt peak photovoltaic system on our road network. First, we have to talk about energy efficiency. When you want to reach some goals in that area, first you have to reduce your energy consumption. We heard a very good presentation with some measures which are taken, and I also want to show you some ideas later. So when we're talking about safety equipment, this is the equipment we're talking about here. So this is what in Austria we typically install. And so to operate a safe tunnel environment, this equipment has to be up and running 24/7. So, and therefore you need a very stable and good quality regarding the energy supply. And now, just to give you an idea, these are the energy consumption figures for ASFINAG for the whole operation. That means everything, including our maintenance vehicles, our company car fleet, the heating of our operational buildings, and the operation of our infrastructure, open road and tunnels. So we a total need of 227 gigawatt hours. And when you look at the breakdown, you can see that 63% was electricity. And when you look at now deeper, you see that the motorway tunnels in Austria consuming then 76%. It means three-quarters of the electricity is needed by the tunnels. And when you look at now a little bit more deeper into detail, you can make a grouping of the safety equipment. And there are some studies available on the market. So by the Astra, this is a Swiss company. So CEDRE is publicating these evaluations. And for Austria, the best split is from CEDRE, what you can see here. And the most important thing is for your situation, your country, you have to see what is the energy need and the split for the equipment. So as we learned, when you have to run ventilation, you need a lot of electricity for the ventilation system, so in terms of traffic jams. So when you don't have to use the ventilation, then the energy goes to other operational equipment. And in our case, we have 4 areas where 90% of the energy is consumed. Is the lighting, the emergency power supply, the signaling, and the air conditioning of our technical buildings. So this is that area where we install our communication equipment and the controllers, the servers, etc. And now I want to give you only a little bit of ideas what you can do or what we do. The first is, as we just now learned, the lighting. So what we do, we install only LED lights. Yeah? What you can see here is the ASFINAG standard tunnel luminaire lamp. So this is another impact. So this, what you can see, is the stainless steel housing. And this housing lasts 30 years of operation. So what we can do, and that is seen on the side, you can open it very easily. And then you can change the chipsets and the LED drivers and keep the housing as it is. So this is for us, we think this is a very good and efficient way of maintaining the LEDs. And the reduction option is depending, but is in average around 30% energy savings. When we look at the tunnels themselves, so we have seen now the Brazil tunnels, which are more or less dark. We believe that bright colored walls and ceilings help to reduce the light. So we carried out an R&D project with one of our universities. And as you can see, you can save 17.5 kilowatt hours with bright walls. And in addition to that, when you light up the ceiling, it's a better effect. Then we have another option regarding the cooling of the technical facilities. Here we have some projects in place where we use the extinguishing water of the standpipe system in combination with heat pumps to also reduce the energy in that area. And last but not least, this is for me, most important technical application for the future in road tunnels. So replacing of the emergency power supplies, the batteries, so the systems are permanently loading, so you lose a lot of energy here. And you use the batteries only as a backup for emergency operation situations. And replacing them by industrial battery systems, which are available now on the market, you can use them in more than one way. You can use them also to store your own produced energy and shift the usage into the night. Or with these batteries, you can use them instead of diesel generators. And when we look at now the measures for generating our own electricity, there are some also international role models. The Zero Energy Tunnel is from the Netherlands. Then you have also a very good report from PIAC, which I recommend, is the PIAC Positive Energy Road report. And all these reports says the same. The road infrastructure should produce their own energy. Yeah? You should use renewable energy sources, and everything should happen on a balance sheet base. when I look at now the situation here in India, you have a lot of sun. Yeah, you will have a better situation than we have in Central Europe. And the upgrading of tunnels to smart grid with a question mark, I show this later. So these are some examples what we do. So this is on the left side is installation next to a tunnel. We're using also hydropower plants when we have water to operate the tunnels, and we're using also our operation facilities where we also operate the tunnels. So in the background you can see a tunnel. So this photovoltaic installation is feeding or is supplying the tunnel. And yeah, some additional information. These are typically operation centers we have, and these are also now getting upgraded with photovoltaic systems. And yeah, we are also charging our own car fleet with the energy we're generating from sun. Look at now at the electricity demand. So we, as we learned before, we have 2018. Okay, there's a little bit of a mismatch. 108 gigawatt hours of demand electricity, and now by 2021 we reduced already by minus 10%, and to reach our strategic goals we have to additionally reduce by minus 15%. When we look at the cost side, because not everything is about green operations, 2018 we had 10 million euros of electricity costs, and this was to 2021 already 11.3 million. So you can see a drop by minus 10% in the need, and the price went up 10%. But this year, or 2022, we had 30 million euros, so 3 times more because of the Ukraine war and the effects on the energy market in Europe. So when we're talking about now the question mark I've shown to you, we can use now these power storage options. And when we look at the self-sufficiency, so this is one installation we have at the Katschberg tunnel. This was on one of the pictures before. We have there 180 kilowatt peak installation of photovoltaics. And this is the production curve. The blue one is what we are producing there, and the gray one is that what the real need is in the tunnel. And now, if we say yes, let's make it bigger installation, and we have enough space around this tunnel. So in Austria, we would have the situation that we can produce more energy than that we can use. And but also with the hydropower plant, you can see the months May till September are well covered, and so we have a problem. But as I said, in India, I think when we look at the photovoltaics, you're in a better place than we are. So this is the PIAC positive energy road model. At the end, it is done for the whole road network you're operating, but it's pointed out especially here for the tunnel operation. And on the other hand, as it is described, the use of solar arrays in that case. And in the middle, you can provide your energy by the local energy grid, or maybe with batteries and photovoltaic power. And why to do this? As I said, when you produce the energy during the day, you can store it and use it in the night. Or you do peak shaving. So before we have seen little generators for these peaks. Here you can do it with the batteries. Blackout resilience, so you're more independent from the grid, and it's a positive effect on your overall electricity network. And what we are talking about now is the road tunnel will be supported in the future by photovoltaics and a battery storage system. And we are using now, what we want to use is our electrochemical storage systems, means batteries. And this is the practical project we implemented. So we tried first to test in our traffic management center in Kärnten. So this is one of our 9 traffic management centers. And here we have this typical installation in place. And on the left-hand side, you can see the production and storage curves. And the red one is the need. The yellow is when the sun is coming and producing electricity. The blue one is the storage. So if it's negative, it gets loaded. And then when the sun is off, the battery takes over. Everything's full automatic, no manual interruption needed. And it works perfectly. And if everything fails, switch over to the diesel generator. But this is only an option. So the conclusion, first, reduce your electricity consumption through measures. Second, promote the expansion of own power. That means as a road operator, produce your electricity yourself. The third, launch a project and see if this industrial batteries in tunnel application works. And then when everything's fine, you switch over to a smart grid functionality. And what we do now, today, tomorrow, we have the construction start for a 16.8 kilometer highway, which is the outer ring of Vienna. We have there are 6 tunnels, and there we're installing 4 megawatt peak of photovoltaic systems and 5 megawatt hours of battery. So we will be there in the position to operate then this highway section with the 6 tunnels for 10 hours with the batteries. That means during the day with the sun, and in the night via the batteries. So, thank you very much, and questions later.
Thank you, Rene, for a wonderful presentation on energy saving issues. Now, the last presentation is by Mr. George Maverin from Australia. He'll be presenting sustainable road tunnels.
Okay. Namaste. I hope I've pronounced that correctly. What I'm trying to say is good afternoon. Now, I'm from Australia, and if you're not aware, Australia and India are fierce competitors in the game of cricket. And in the game of cricket, when you're fielding, you usually start with your fast bowler, then you'll bring your medium fast, and then later you bring your spin bowler. And in this team, I'm the spin bowler. Now, you'll have to listen very, very carefully to my presentation because you don't know whether I'm going to bowl leg spin, off spin, or bowl straight. So listen carefully. Road tunnels require significant resources and energy to construct, operate, and maintain, so they are potentially a major source of greenhouse gas emissions and environmental pollution. Could be a problem there. Developing practices to improve the sustainability of road tunnels is necessary to reduce the pressure on scarce resources and the natural environment. What is sustainable development? There are various definitions of sustainability used across the world. According to the United Nations, sustainability is meeting the needs of the present without compromising the ability of future generations to meet their own needs. PIARC suggests that the development principles that support the 3 sustainability pillars, economic, environmental, and societal impacts, represent a widely accepted interpretation. Sustainability in relation to infrastructure requires a life cycle approach to achieve desirable sustainability outcomes. From the planning phase to design, construction, operation, and through to the maintenance phase. A life cycle that is typically more than 100 years long. In 2017, PIARC published a report titled Road Tunnel Operations, First Step Towards a Sustainable Approach. It is report number 2017 R02EN. You can access it from PIARC's website. This report defines the concept of sustainable development and in particular its relevance to road tunnels. The report provides an inventory of the main methods that can be used to assess the impact of initiatives undertaken within a sustainable development approach. It includes initiatives and actions for a more sustainable approach. The report has recommendations and suggestions for future studies in the field of sustainable development. If you haven't already read this report, I highly recommend that you download a copy from the PIARC website and that you read it. The concept of sustainable development is based on three pillars of economic, creating wealth and improving living standards; environment, preserving species, natural resources and energy resources; social, meeting needs in terms of health, education, housing, employment, etc. These pillars are given a lot of attention in preparing a business case to propose road infrastructure, including whether to incorporate a road tunnel or not in the proposal. These pillars are not independent, they interact with each other. For the economic pillar, consideration will be given to things like road user benefits, journey time reliability benefits, and wider economic benefits. For the environmental pillar, this is about providing environmental protection to reduce impact on air, water and earth. For the social pillar, a tunnel can have a positive impact on the health of people and living conditions by separating local residents from the effects of road infrastructure. However, a tunnel design must make sure that conditions at tunnel portals do not adversely affect the health and well-being of people. Now, I've presented just a few points of each of the three pillars in the planning and the design phase. Consideration of these pillars should extend into the construction phase and the operation maintenance phase. A measure or a set of measures for a road tunnel project can only be considered truly sustainable if all three sustainabilities are supported. In practice, this is rarely the case. For example, construction of a new tunnel may be beneficial for the economy and have social benefits, but may not be positive for the environment. So the choices made for sustainability are the result of a compromise across the pillars using multi-criteria analysis or benefit cost analysis to quantify the effects. How do you measure sustainability? Well, in Australia, we have established the Infrastructure Sustainability Council, and one of its main functions is to rate infrastructure sustainability. When infrastructure is designed, the designs are presented to the council for rating. At this time, the infrastructure developer gets a good indication from the rating as to whether their proposal will meet the client's sustainability requirements or not. The rating tool that's used is based on environmental, social and economic criteria. If the proposal does not meet the specified rating, the design can be modified to try and achieve a higher rating. So this is the time really that you're really putting a lot of effort into getting your planning and design right to get the best outcome and minimise your costs. Following construction, drawings show the as-built condition of the infrastructure are again submitted to the council for rating assessment. If the sustainability rating of the constructed infrastructure falls short of the client requirements, well, it's too late. You can't go back and reconstruct what you built. So some clients, they can impose a significant financial penalty on the developer as a result. Let's have a look at how sustainability fits in with the life cycle of a road tunnel. The greatest opportunity to improve a tunnel's sustainability rating or performance are available in the early stages of the life cycle. That's in the planning and design phase. Setting up sustainability targets and then designing and constructing to meet the targets. Options to further improve sustainability performance are significantly reduced in the operations and maintenance phases of the life of a road tunnel. When a tunnel undergoes refurbishment, there are some opportunities to improve sustainability depending on the scale of the refurbishment. New, more sustainable technologies may be retrofitted to an existing tunnel, such as lighting and ventilation systems that are more energy efficient. We've already heard that from the previous speakers. The figure on the right of this slide is from the PIARC report, Road Tunnel Operations, First Steps Towards a Sustainable Approach. According to the PIARC report, the impact of the planning and design phase is significant, in the order of 60% to 80% on operating and maintenance costs. The decisions made in the initial planning and design phase have the greatest influence on life cycle costs. Now look at barriers to sustainability, starting with contractual requirements. While sustainability requirements may be included in contract documents, sustainability may not be given significant priority. For example, when a sustainability opportunity arises, if it conflicts with the time or cost objectives, unfortunately the sustainability opportunity may be dropped or reduced. Clients who govern the writing of contract documents and the procurement process have an important role to play. Clients should clearly state their commitment to sustainability outcomes and their expectations. The approach challenges and drives the construction industry to invest in developing and implementing sustainable initiatives. Approval to the use of new materials. In response to the challenge of improving sustainability, the industry is showing initiative and in developing new materials, such as using waste glass to replace sand in concrete. A significant barrier to the use of such new materials is the lack of standards to govern the material quality. This makes it difficult for all parties, the designer, the contractor, the project owner, and the material supplier. Processes for managing the use of new materials may work in contracts with relatively long durations, at least 4 or 5 years. The development and testing of new materials to reach acceptability is a long process. So it's important to also set up processes outside of contracts that encourage research, development and approval of new materials. Clients have an important role to set up this arrangement, to invest in research and to work in partnership with industry to really accelerate the development, approval and use of new materials, sustainable materials. Relatively higher costs of some sustainability measures may be a barrier to their adoption and use. It would be helpful if clients provide financial incentives or rewards to encourage the development and use of more sustainable measures. I hope you're still listening tight, because I've just switched from leg spin. I'm now going to go to off spin, so be very careful. There are other barriers to ongoing improvements to sustainability, such as a lack of political will to invest in sustainability of road tunnels, lack of policies that require sustainable outcomes, lack of experience in sustainability assessment, perceived operational risk associated with previously unused sustainable products, and the list of barriers goes on. It's very important that we identify all barriers and find ways of dealing with them. Let's have a look at some sustainability initiatives that are relevant to road tunnels and also on the open road network. Firstly, pavement materials. The use of rubber from old tyres has been used in spray seal surfacing of roads for many years. Now, much greater use of crumbed rubber is being developed for asphalt materials. Crushed glass is also being trialled in pavement layers and for the use in bedding materials for drainage. Crushed concrete and crushed bricks are being used in pavement layers. Apparently, the fines in crushed bricks have a characteristic that is similar to a cementitious binder, so that's really promising. You'll see in this slide there's a reference to another PIARC report. It is report number 2019 R32EN, titled Green Paving Solutions and Sustainable Pavement Materials. It's worthwhile reading this, and it can also be found on the PIARC website. Recycled glass in concrete. Concrete includes aggregates made of sand and crushed rock, which constitute 65 to 80% of the mix. Approximately 50 billion tonnes of aggregate are used annually globally. In Australia, recycled crushed glass is beginning to be used in concrete to replace sand and in asphalt mixes. However, many standards do not permit the use of glass in some grades of concrete. At this time, the risk is considered too high to allow recycled crushed glass in the higher quality grades of concrete. Looking at geopolymer concrete, that's regarded as a low carbon concrete. Geopolymer concrete is made with a geopolymer binder rather than cement. Removing or reducing the use of cement is important because the cement production process creates a large amount of carbon emissions. Cement production accounts for 5% to 8% of the world's carbon emissions. That's enormous. Geopolymer binders can use various waste products such as fly ash, blast furnace slag, as shown in this slide, palm oil, fuel ash, and mining waste. There are other benefits of using geopolymer concrete, such as less shrinkage than conventional cement-based concrete and potentially better tensile and flexural strength. The main barrier to the use of geopolymer concrete is the lack of standards. In Australia, there are developments to amend the structural concrete standard to provide for geopolymer concrete. Another barrier is cost. Geopolymer concrete is currently approximately 10% more expensive than conventional concrete. However, once this type of concrete is permitted in standards, it will be used increasingly, and through economies of scale, it will become more cost competitive. Another emerging factor which will assist the adoption of geopolymer concrete is the weighting given to carbon costs. In the UK, the government is looking to award economy boosting funding to projects which demonstrate a commitment to low carbon technology. I spoke earlier about the use of fly ash and blast furnace slags to reduce the cement content. I've recently learned that because we are planning on reducing coal-powered stations and changing the way we produce steel, we can expect to run out of blast furnace slag and fly ash in the not too distant future. This is disappointing, but there's some good news. We have found that calcined clay is a good additive in a concrete mix to reduce the amount of cement. It has the potential to reduce the cement content by up to 50%. Now, trials of 40 megapascal concrete with calcined clay are underway in Australia. I understand that the clay in Australia that's being used for the trials is very similar to what you find here in India and over in Europe. So it's very promising. Calcined clay in concrete results in 80% less production energy, 70% carbon reduction, and is up to 30% cheaper. So it really is promising. I hope those trials turn out to be really positive. Spoil reuse. The construction of tunnels generates a significant volume of excavated material. Rather than dump the excavated material into landfill or create earth mounds, better value can be gained by repurposing the material to avoid the need to source scarce higher value materials. If the excavated material has an adequate strength, it could be crushed and used as paved material. If the excavated material is softer than rock, it could be mechanically stabilised and used in the lower layers of pavement construction. Mechanical stabilisation is used extensively in road building. Here the added materials are shown as lime or cement, not really sustainable additives. Another way is to mix natural unprocessed materials to upgrade the quality of the mix. Looking at portal emissions, most road tunnels in Australia are not allowed to have portal emissions. To achieve zero portal emissions, all tunnel air is discharged through the tunnel ventilation outlets, which requires pulling air at the tunnel exit portals against the natural direction of flow, the piston effect. This requires the tunnel ventilation system to operate 24 hours a day at a significant cost in energy consumption. Environmental licensing authorities are favourably considering proposals to allow portal emissions at times of relatively low vehicle use, for example from 8 p.m. at night to 4 a.m. The Eastling Tunnel in Melbourne had its air emissions licence amended to allow for daytime portal emissions in addition to nighttime emissions, mainly because energy conserving upgrades to the ventilation system were introduced. The energy savings were in the order of 68%, saving approximately 9,000 tonnes of carbon dioxide each year. Quite significant. It's looking at immersed tunnels. Based on AECOM's recent experience, some clients request the construction industry prepare proposals to design and build an immersed tunnel in a harbour. AECOM's analysis is that a tunnel boring machine tunnel solution provides for around 80% reduction in carbon emissions compared to immersed tunnels. Quite significant. In a recent tender, AECOM proposed a tunnel boring machine tunnel proposal, and as an alternative to the client's request for an immersed tunnel, and the client accepted and adopted the tunnel boring machine proposal by AECOM, which was encouraging. Looking at ventilation fans, a necessary piece of equipment in many tunnels, and we've heard about that with earlier speakers. The use of efficient variable speed fans is worth considering. A tunnel operator stated that variable speed fans governed by tunnel air quality can save around 60% of energy required to run fans at normal speed. In South Korea, they are undertaking a trial to harness the energy created by tunnel fans when they are not in use. When the fans are not switched on, they spin around because of the piston effect caused by vehicles pushing air along a tunnel. This energy created by the free spinning fans can be captured and stored in a battery for later use when the fans are switched on. Transportation of materials on our construction sites. Greater use is beginning to be made of alternatively powered vehicles for construction, that is, alternative to fossil-fuelled vehicles. We are learning that some construction companies are planning to use electric vehicles and hydrogen-powered vehicles for the next generation of their projects. In fact, alternatively powered vehicles are already being used by the Australian mining industry. Diesel engines for mining have about 45% efficiency. electric drivetrains can hit an energy efficiency of around 90%, twice the efficiency of diesel engines. A standard diesel-powered dump truck used in mining uses between 50,000 and 100,000 litres of diesel each year and emits between 130 and 270 tonnes of carbon dioxide a year. I think their life is short-lived. New generation projects can involve the preparation of environmental impact statements that include climate change risk assessment. This includes projects with tunnels. The assessment of climate effects needs to cover the construction phase period, typically a period of around 4 or 5 years, and also for the long term, so the next 60 years or so. Greenhouse gas impacts assessments may also be undertaken. In the process of planning, designing and constructing our road tunnels and the connecting surface road network, we must give careful consideration as to how we will minimise the impact on the environment. For example, in Australia, our current practice is to rate the quality of the native vegetation at a project site, and for each native tree that is removed, you must replace it by another tree or 2 trees, and depending on that quality, the value goes up. A really highly valued tree might mean that you've got to replace it with 20 trees. And if you can't replace with any trees, then you may have to make a financial contribution to enable purchase and planting of trees nearby the construction site. We must also give consideration to minimising the impact on waterways in close proximity to our projects. I'll keep moving. I strongly believe that we can successfully develop and deliver sustainable road tunnels. To achieve this, it requires leadership by various participants in the process. We rely on the leadership of clients, who are typically government departments or authorities, to make clear what their requirements are for sustainable road tunnels as part of a sustainable road network. We rely on leadership from our planners, designers and constructors to develop and implement tunnel solutions that meet client requirements. If there's a lack of government directive or requirements, we need our infrastructure deliverers to show initiative and leadership and proceed to implement sustainable road tunnels anyway. Sustainability and sustainable road tunnels are currently topics of significant interest to our current generations, and we expect increasing interest and expectations by future generations. I believe we're at the beginning of finding effective ways of making sustainable road tunnels. We need to continue on this journey and use our very talented and smart resources in our industry to develop and implement more effective and efficient ways of making road tunnels more sustainable. Our industry has many strong leaders and great innovators that can successfully get us to the point where our communities and governments are satisfied that road tunnels are sustainable, and as a result, the demand for more road tunnels will continue. Dhanyawad. Thank you.
Thank you, George, for a fine presentation and within the stipulated time allotted to you. Now the floor is open for discussion. Because of shortage of time, we will request the delegates only put forth straightforward questions to the concerned speaker. And the volunteer can give the mic to the concerned delegates. Please introduce yourself and raise your questions or doubt to the concerned speaker only.
Good evening, everyone. I am Larry Gupta, technical consultant, Ministry of Road Transport and Highways. I have a question for Ricardo Miranda. You said something about artificial intelligence in electricity consumption. So how do you think that in current scenario, artificial intelligence can reduce the consumption of electricity in tunnels? Thank you.
As understood, the consumption in city tunnels.
Yeah. The use showed a chart that represents the kilowatt hours consumption in electricity in all the tunnels.
Yeah. So there are two, in my opinion, there are two, but maybe Rene can answer better your question because he has more experience in that. But we have to make sure that we are delivering to the drivers or to the people who are using the tunnel exactly what they need. I mean, you have to deliver them the right air quality. Doesn't mean very good air quality, because sometimes the air quality outside the tunnel it's already terrible, so it's difficult to give a better quality inside. And the north light, let's say, according to the requirements. But these are the most important things to be in mind. But you have to adapt to the situation, let's say.
Thank you. I think Rene can have a better answer for this.
Can you please repeat the scope of the question?
Yeah, actually, both of you emphasized on electricity consumption in tunnels. Like you said about cutting the white color tunnel walls so that electricity consumption can be reduced. And there was a chart representation of artificial intelligence in use of electricity consumption. So at present moment, is there anything related to artificial intelligence that caters with electricity consumption as of now? Any tools or something like that?
Yes. I think when you start to design the tunnel, let's say, go back, what is the requirement? Normally, you have a legal situation which is different in each country. And adapted to this legal situation, you start to design the tunnel. So also for us, when there's a requirement for 4.8 candela per square meter, we have to start the design for the light adapted to this requirement. So this is the first. The second is then during the normal operation phase, you have to implement systems where you can continuously measure the energy required, the energy need of the different systems, and out of this measurement, you can then adapt your actions. Let's say. When we look at the lighting, we in Austria also do something like tunnel washing, because we have a lot of dirt and dust, and this dirt and dust makes the tunnel dark, and also the luminaires, they get dark, and then you get not enough light out of them. So one of the actions, then you have to wash the tunnel, and if it's not enough 3 times washing, you have to adapt and maybe wash it 6 times, and then what is really important is do something like calibration of your sensors during the operation. That means continuously calibration and look that all your controls are working fine. This is one of the most important things. So, and from there on, when the calibration is working, you have a good measurement in place, you have to define what you can do to come down with the energy consumption. But this is from my opinion, always related to the local situation, to the structure you have, because the tunnels are not all similar. All tunnels are different. So this is the biggest problem with the tunnels we have also in Austria. We have 166 tunnels, and no one is similar to the other. So the engineers have to be also well trained. They should know what they do. They should know the infrastructure. And this is also important. Training of the people, have good electricians in place. So, yeah.
Thank you.
A good mixture.
Thank you. Just to add to Rene and Ricardo, I think in Ricardo's presentation, there is one concept of design he explained, that even the type of painting and the color can also make the luminous requirement intensity different. So at the design stage, you can find out maybe what type of color that should be painted in the tunnel, what type of paving material that should be there. That actually gives you how much energy can be set because of that lighting improvement and things. That is one of the presentation he made. Thank you. Any more question?
Good afternoon. I am Dr. Ravindra Kumar from CSIR Central Road Research Institute.
Please be loud.
My question is with Ricardo. It's regarding like you mentioned about that you have installed the NOx sensor, CO2 sensor in tunnel, right? And as we are aware that in the tunnel it's an enclosed space and air quality, air is almost stagnant there, then it's very difficult to maintain the air quality, right? Apart from within the tunnel air quality, there are inside the car also we have the indoor, or inside the cars also there will be issue of air quality. So keeping in the constraint and keeping the challenges like tunneling effect, and then there is no open air circulations, then how we are going to maintain the air quality in the tunnel? And suppose if it is long tunnel, especially, and where there is long queue of the vehicles, then again there will be, if headway between vehicles is very less, then of course there will be continuous emissions coming out from the exhaust. So how to control it and how to manage it in such conditions? That's the question with the Ricardo.
So, I'd like to comment something. Is this tunnel, this our example, is a bidirectional traffic tunnel? Yeah. So this is a huge discussion. If you are building a very long tunnel, be careful with that. I know that sometimes the tunnel is designed according to the traffic volume, and the traffic volume normally does not require twin tube system. I mean, two different tubes. But if you build a big tunnel and bidirectional traffic, I don't know any other way to keep the air quality good unless mechanical ventilation. We have to ventilate the tunnel. It means we will spend a lot of money. Just an example, in São Paulo city, there is a tunnel that it's in operation for 37 years. And the tunnel operator is the municipality, and the guy there is an engineer who started his own career in this construction, and he's there for the whole life. So he has a big sheet with electricity consumption for the whole 37 years. And we calculate how much money the municipality spent to keep this tunnel ventilated, only to ventilation. And it costs us 3 times more than the construction of the tunnel itself. It means if the municipality take the decision 37 years ago to build a twin tube system, of course the construction cost will be a bit higher, but first of all, we don't need a second tube now, and we could save this amount of money. So I don't know another way, but in this case, we have to ventilate. Another important thing that it's maybe India has to implement, I don't know if it's implemented, it's vehicle inspection. So in Brazil, for more than 20 years, it's mandatory to make vehicle inspections to renew your license. It means you have to give maintenance to your car, you have to put the correct filters on it, you have to keep your engine clean. In this case, the emissions have gone down a lot in 25 years. So this is something that it's a public policy that can help in the tunnel, but I know that takes a lot of time. It's not something for tomorrow. For tomorrow, I have to ventilate mechanically. I don't know a different way to do it. But please do not install filters in the tunnel, because this normally doesn't work. It gives you a better idea that the problem is solved and consumes a lot of energy as well, a lot of money. But dilute the pollutants using mechanical ventilation, if I can recommend.
Okay, thank you.
Yeah.
Thank you, Ricardo. I think one more question only will take.
Good afternoon. Good afternoon. Is it clear?
It's not audible. Not audible.
Good afternoon. I'm Abhay Kumar, ex-Chief Engineer, Ministry of Defence. My question goes to Mr. George, our cricket competitor, and then to Mr. Rene. Mr. George, for sustainable road tunnels, what is the lifespan you are considering for a life cycle cost? And then to Mr. Rene, how much is the percentage of hydrogen power of the total electricity being used in your presentation, what you have given for Austria, and any byproduct of the hydrogen power like oxygen also being used in your project area or not?
Yeah. I don't think there is a standard amount of time that's utilised for life cycle costing, but typically we design our assets with a life span of around, for structural assets, of 100 years. But from what I can understand, the analysis for benefit cost purposes usually stretches out to about 60 years or so.
100 years for the structure, but you have in your presentation shown so many, equipment and other things for the life cost also. So average you are meaning 60 years?
Well, the calculation of benefit cost analysis, you can look forward to whatever period you like, but typically you would look out to around the 60-year mark to try and get a better appreciation of comparing what your various measures might lead to. Yeah.
Okay. Mr. Rene, please.
Yes, I want to give a little bit more general answer. Yeah, so when you're operating a highway, you have first to see what kind of potentials you have for alternative energy production. So when you look at your network, I don't know it, but in our case, we have also the options to use windmills, yeah, and smaller windmills, larger ones, to use photovoltaic systems for the noise barriers, or on the roofs, or on the open field. And the third is use some water, what is there. And when we're talking about the hydro, it's zero. Yeah, so we have in place two installations, and when we do this, when we have enough water coming out of the mountain, because this is always...
Sorry, I'm not asking for the hydropower.
Hydrogen.
Hydrogen power are being used?
Hydrogen. No, zero. Nothing. So...
You mentioned somewhere, I think, hydrogen power? No.
No. Hydro. Hydro.
Okay.
Okay, thank you. I now request my co-chair Arthur to sum up about the presentation.
Excuse me. My name is Sunit Dhar.
I think you have taken the last question already. You have taken. Yeah. You can interact during the tea break, and we have shortage of time.
Okay, thank you.
Okay. Thank you very much, Mr. Chairman. Big job to conclude this excellent presentation of my colleague Ricardo, René, and Georges. I want to thank them for the quality of their presentation, and also for the new idea in the term of sustainability. First, for Ricardo, he presents a project from Brazil, Tamios tunnel project, and he shows how to take good decision in the initial phase of the project in order to reduce the cost of operation in the tunnel. And I was also very happy for this presentation because Ricardo used the recommendation from the report of PIARC, the recommendation from technical rapport of 2006, where the recommendation tell to owner sometimes it's better to use a generator in place to buy electricity from the grid. It's very, very good example to see that recommendation of PIARC are using around the world. And also a good idea in the presentation of Ricardo is the calibration of the sensor. The calibration of the sensor in the tunnel is very, very important, because if you have a bad calibration, you can have a bad functioning, and the bad functioning can conduct you to energy consumption for nothing. You must pay attention about that. Now I can move to the presentation of René Lis from Australia. What is was very good.
He's from Austria.
Oh, Austria. I'm sorry,
He's Austrian.
because he disturbed me. Yeah. The presentation of René was very clear, and something was very, very good is that in Austria they have a vision for the sustainability. Their vision is to reduce 20% in consumption of the energy. I think it's very, very important to have the vision in the kind of that domain. And René talk also and give example used in Austria to reduce consumption of energy by using solar energy, also by working in the bright color of the wall of the tunnel in order to reduce energy consumption by lighting in the tunnel. And what was also important in presentation of René was the analysis of the demand of the consumption in the tunnel and give a response for that demand. I think that in that domain, it's important to use technology like data mining to analyze data. As one authority said this morning, it's that field you can use intelligence artificial in order to manage data and to go to the consumption, to reduce consumption of the energy. And the third presentation made by Georges was very clear to present sustainability in 3 pillars: economic, social, and environmental pillar. And it showed also some contradiction between economic pillar and environmental pillar. Georges gave also example in the cadre of sustainability to have innovative material like geopolymer, recycling of plastic, and also in the presentation, he'll give an idea to authority to take a sensitive measure in order to promote sustainability in the tunnel, and also he tells that the government must have a clear vision about sustainability. If the government is a clear vision, and the technician can decline solution and so on. Okay, I think that I summarize the presentation of my colleague, and I thank them also very much, because this subject of sustainability is not easy to understand and to manage. Thank you very much for your presentation.
Thank you, Arthur, for very nicely summing all the 3 presentations. Dear delegates, just as a closing remark, I should inform that we have 3 wonderful presentations. One from Brazil by Ricardo, one from Austria by René, and the last one from Australia by George. In 2 of the presentations, they touch quite often on the energy saving and monitoring of the noise, air quality, and energy through various types of sensors and monitoring devices, and how they can reduce that also, optimize that. Very nice presentation, both of them. And in the presentation of George, he has emphasized on sustainability from the construction point of view, from the operation point of view, and also from the maintenance point of view, starting from material, recycling of the material, advanced material, and so on. So there's a very nice presentation touching the operational challenges and also including the sustainability index. Only I want to know, George, even if the life cycle cost that was asked by one of the delegate, when you do a life cycle analysis for a road or a bridge work or a structure for the service life period, we always put certain parameter for the initial costing, the maintenance costing, operational costing, and also give parameter for the social and environment related costing. Is it the same in case of tunnel life cycle costing, or any other thing is being done? And what are the analytical tool? Like SDM4 is one of the popular analytical tool for payment life cycle analysis. What are the analytical tool globally used for life cycle analysis of tunnel? That is my last questions, maybe, before we close and with the mementos and session closing.
No, yeah, it's not an easy question to answer, because I don't think there's a standard way of doing it. I think the best thing to do is to have a look at the various measures that you're looking to include, and look at the options, plan them out, and then do an economic forecast based on that, and then maybe swap around some of the measures and try it again. But the risk is that the further you go out in time, I mentioned go out to 60 years, once you start projecting beyond that, you start to lose the sensitivity of the costing, because really, once we get past 20, 30 years, who knows what the costing is really going to be like and what new materials might be introduced between now and that period of time. So you really need, it's good for decision-making purposes, but it's not absolute.
And also the technology changes, the sensors,
Yeah.
everything changes.
Yeah, exactly. So
Thank you, thank you.
With now discussions and questionnaire on the conclusive end, we thank every presenter and our chair and co-chair present today. To thank which, I request Mr. Pranav Kapoor, Vice President IRC, to come forward and felicitate our chair and co-chair, along with all the presenters. Considering our session 3B a successful discussion on sustainable road tunnel operations, I now declare this session for a hiatus again and request everyone to enjoy their high tea with a break of 15 minutes. We shall convene again in the same room after 15 minutes. Thank you, dignitaries. You may lead and head towards the high tea.
Thank you.
Dr. Cha, thank you to meet you. I give you my.
I'll also give my card.
Oh, yeah. I come from Belgium.
Yeah.
I have
My presentation with this one. Yes.
Okay.
He needs to, like, उनको पुराना वाला जो है वो बदल के Good evening, guests. Theodore Roosevelt once said that believe you can and you're halfway already there. With this belief in our hearts, we have finally reached our final session for our day. Previously, having discussed about ventilation and fire protection, along with sustainable road tunnel operation, we move forward with our seminar through this session where we pivot all our attention towards the safety issues regarding the agenda of our seminar. We glide through this seminar in the presence of our Honorable Chair, Mr. Eric Primat, ITA COSUF Chairman, and our Co-Chairman, Mr. Rahul Gupta, Chief Engineer Morth, and member of PIARC-T's Technical Committee 4.4, while focusing our contemplation towards the understanding of intelligent lighting control, not only for safety and energy savings as well, edified to us by Mr. Pierre Longton, member of PIARC-T's Technical Committee 4.4, Canada, Quebec. Aspiring to understand self-evacuation process, reduce mobility by users, presented by Mr. Hélène Mongeot, member of PIARC Technical Committee 4.4 and ITA COSUF, France. Contemplating the ideas for new digital approaches for safe operations and tunnels, put forth by Mr. Arild Sovik, member of PIARC Technical Committee 4.4 and ITA COSUF, Norway, with which we shall be concluding for the day. We are honored to have all of the chairmen at this event. Your presence has added a sense of grandeur and prestige to this occasion, and we are grateful for this opportunity. I would like to now invite all of the committee to the high table and guide us through the event. We believe that your insights and expertise would greatly enrich the knowledge and understanding of our audience. Distinguished guests, ladies and gentlemen, it is my privilege to extend a very warm welcome and express our sincere gratitude to our esteemed committee. For this, I would like to invite V.S. Khera, Chief Engineer Morth, to come forward and felicitate our panel for today. Thank you, dignitaries. We will now move forth with this session. And now, I hand over the procession of our seminar to our respected committee.
All right. Good afternoon, ladies and gentlemen. My name is Eric Primat. I am a member of TC 4.4 of PIARC. And also, I am the chairman of ITA COSUF, which is the technical committee of ITA in charge of operational safety for underground facilities. I will be chairing together with Rahul Gupta this last technical session about safety. I'd just like to remind you to stick to the agenda. It's a 20 minutes lecture. And if you have questions, please take them in mind and note them. And we will have a question and answer session at the end after the 3 lectures. So I don't know, Rahul, if you want to add something, or
you can go ahead with the.
Okay, so maybe it's time to move on to the first presentation by Pierre Longton about intelligent lighting control, not only for safety, energy savings. Please, Pierre. Do we have a short biography? No. Just to sum up, that Pierre Longton has been involved in tunnel lighting for many years, and he has founded a company, and he's now in charge of the different projects, I think everywhere in the world, and he's got a long time expertise about communication, intelligent control systems. And now you are the CEO of Nix Hemera Technologies. That's true. And yeah, I think that's most important thing. And now it's time to you to start with your lecture. Thank you.
No, not the paper, the presentation. Your presentation is not for. Yeah, I sent yesterday by email. Give me pen drive? Not with me, on my computer. Can I go to grab it? No, just put. You're gonna. Sorry. Yeah. Yeah, two. Okay. So sorry for the technical problem. It's resolved now. So again, I'm Pierre Lontin from Nexamera Technology. So I'm going to present, you've seen the previous presentation, lighting control system for road tunnel is something that is a system, one of the biggest in terms of energy consumption and all this. So my presentation today will be a presentation of different lighting control system in terms of control, but also how to use it to diagnose if there's a problem with the system, how you can use the control system to find a problem without closing your tunnel. So why installing an intelligent lighting control system? First point will be to reduce the cost. You see in the previous presentation, energy consumption for the lighting system can reach up to 60% of your energy costs. So that's something that you want to reduce and optimize the control system. Supports sustainable development. Again, on the previous presentation, that was one of the key elements. You want to reduce your energy consumption, your footprint to the earth. So increase safety. The lighting in the tunnel is a safety element. If you don't have light, that may create accident or different problem. The lighting system is not just to not really use it play an active role that, and we're going to see later on the tunnel operation. And of course, facilitate the operation, the maintenance. You know that closing a tunnel to do maintenance inside the tunnel costs a lot of money. So how we can use the control system to remotely diagnose the problem. So when you arrive inside the tunnel, you fix it and you reopen the tunnel. That's one of the objectives here. So again, the cost of the lighting control system is very high. And depending on the size of the tunnel, on very long tunnel, the ventilation, depending if it's a single tube, two tube, ventilation may be high. But on a small tunnel, underpass, something between 500 meters to few kilometers, the lighting control system is your system that will cost you the most. So this is where you want to optimize as much as possible. The speed, the entering speed inside the tunnel will also have an impact. If you reduce the speed, you can reduce your light level. It's part of the standard that we're going to see. And that's another place to reduce the energy cost. In the previous presentation from Brazil, if you recall, they mentioned that they control the lighting system depending on the speed of the traffic. So that's a good way also to reduce the energy cost. So there's different standards related to the safety in your lighting system. In North America, we have what we call the RP8, which is a standard that defines the light level that need to be applied inside your tunnel in the different transition zone, threshold zone, transition, interior. We have in Europe the equivalent standard, which is CIE 088. Both standards have been revisited recently due to the addition of the LED system. Both standards are very, very similar, although there are some minor difference between the two. The idea of the lighting control system is basically to avoid the black hole effect. So when you drive inside the tunnel at a certain speed, you enter into a black hole. So what you want is to have a lot of light at the entry of the tunnel to avoid that black hole effect. And as you drive through the tunnel, then you can reduce your light level because your eye will adapt properly to the interior of the tunnel. With the addition of the new luminaire, the LED, that creates a new effect, the glare effect. If the tunnel is too bright, that causes exactly the inverse. So you have to have exactly the right light level for the driver. It's a safety issue. In previous system, when we use lamp sodium, the typical control system was really basic. It was a typical contactor base where you basically switch on and off. There's no dimming with high pressure sodium lamp. So you switch on group of luminaire. It can be 50, 60, 100 of luminaire in a group that you switch on at a certain time. And typically those previous systems use 2-3 level, 2-3 group. So that use a lot of energy and a lot of consumption. The new system, basically with LED, there's two different types of systems that we're going to talk here. First, you need the power. You need to bring power to your luminaire. Without power, of course, your luminaire will not work. In some systems also, they install control cable. We will see that there's maybe an alternative option to control cable to optimize your system. Using a standard control cable in a tunnel environment, that's a lot of connection between your luminaire. You have to think that a luminaire system in a tunnel is not 2 or 3 luminaire. It can represent 500, 1,000, multiple thousand of luminaire. So having a control cable connect to each of your luminaire, that's a lot of connection point inside your tunnel. Adding to that, the control cable will need to go through conduit, junction box, put a lot of luminaire in series to a communication control bus. So that's a lot of equipment that you install inside your tunnel, which may be not the optimized way to do the control system. The other solution or alternative is to use the power line communication. You already need a power to power up your luminaire. Adding a power line communication is basically not using standard or independent control cable, but you reuse the electrical power cable to inject a high frequency signal on top of your 50 Hertz, 60 Hertz. So you minimize the infrastructure inside your tunnel. the power line communication has been developed many years. The first power line control system, not necessarily for tunnel, has been developed in 1970. So it's not a new technology. It's a technology that has been developed for many years, and of course, as all of the other technology has been improved. Right now, we do have some technology that combine multiple type of communication technique, very similar to your cellular modem. If you are in a high city with very good connection, you will be on G5 connection. If you are in a lower connection, your system will adapt to edge or to a lower communication speed. Very similar technique applied to power line communication. Again, the previous system used typical 3 lighting stage to power up your system. It's based on external sensor. It was also present on the previous presentation, the luminance photometer. So basically capture the light level at the portal, send this to the lighting control system, and adjust the light level. So previous system used very low lighting stage, which is not really optimum for energy saving. So when you have advanced lighting control system, we can multiply the number of lighting stage as required. So you can apply 10, 20, 25 lighting stage in your system. So you basically line up the right light level according to what is outside the tunnel. So that's really a way to optimize the lighting stage. The other nice feature of the new the lighting control system using LED is the system can compensate for other variables that will affect your lighting system in a tunnel. First, the dirt depreciation. So as a car go through the tunnel, there's a lot of carbon monoxide that will go to the light. That will reduce the light level. A system between cleanup of the tunnel and your luminaire, let's say you do a cleanup every 6 months, during that period, the system can compensate for the dirt depreciation. So basically the system with sensor installed inside the tunnel, like luminance photometer, the system can compensate and increase a little bit the light level to compensate by the dirt depreciation. Also, the LED, the electronic, the LED has a certain lifetime, typically 100,000 hours of operation. Over time, they reduce the light level. They lose some physical characteristic and they lose. So the system can compensate also for that. So as soon as the light is on, the system can calculate how many hours each luminaire has been on and compensate over time for the light loss factor. So these are different techniques to improve your system and make sure that you have the optimized system that will reduce the energy consumption. So that's a typical lighting control system used in more and more tunnel. But how to use that system in troubleshooting? Because that's also a good reason to have a good control system, is to have a way to determine what's the failure. So when you enter to the tunnel, you know exactly what to resolve. Whoop. Not this one. Whoop. Okay. Missing. Okay, I don't have, there's one slide missing, I don't know why. I will explain a case study. So, and it's a real case that I use here. So we have a control system installed in the tunnel, and we have the operator that call us and say, we have, I don't know, around 700 luminaire in that tunnel, and the operator say, we have 6 luminaire flashing inside the tunnel in a row. I think we have a problem with your control system. So I'm going to ask a question to you. Is the problem with the control system or the luminaire? Who think that the problem was with the luminaire? We have 6 luminaire in a section of the tunnel that's flashing all together at the same rate. Raise your hand for the one who say that is the luminaire problem. Who says the control problem? Okay, so let's try to figure out. So on that particular project, commissioning was completed, but we are under supervision and maintenance on that project. So the operator allowed us to connect remotely to the system and try to figure out what was the problem. So we dig into the database and try to retrieve all of the data information about those luminaire. So we retrieve all of the electrical parameter, power factor, consumption, latest status. So we saw that after a certain time, the luminaire reset itself. So we dig more into the database, into the system, the SCADA system, to retrieve all of the log, all of the information. The tunnel is still in operation. The car is driving. They have not closed the tunnel. It's only 6 luminaire. It's not a safety issue, but they want to resolve this. So after a certain time, we determined that the problem was not the control system, but the electrical distribution. The neutral in the junction box has a loose connection for those 6 luminaire and have a bad contact. So at the end, after less than 45 minutes, we find the problem. The team entered the tunnel, close only one line, and basically find a terminal block that have a bad connection that burn inside the junction box. So the problem was not the control system, but the control system with all of the data and the diagnostic that has been recorded, we've been able to find the problem, and they closed the tunnel for less than 45 minutes and resolve that problem. Thank you.
So thank you very much for this very interesting talk, Pierre. And now it's time to move on to next speaker. So her name is Dr. Hélène Mongeau from France, from CETU, which is the French National Tunnel Study Center. So I'm trying to give her a biography, but she studied in civil engineering, had a PhD about traffic modeling, I think so. And she's been working at CETU for many years, first being in charge of the operational department, and she moved on to the safety department, and she's now head of this safety department. So, trying to fix some technological problems. So Hélène, you are going to talk about self-evacuation process, including the reduced mobility users, and the floor is yours.
Thank you, Mr. Chairman. Good afternoon, ladies and gentlemen. The topic of my presentation today is an overview of the French experience on the self-evacuation process, including reduced mobility users. First, I'll give a word about the context of safety in a road tunnel. Then I'll go through the basis for the main safety measures in a road tunnel. Then I'll tell you about adapting safety equipment to user needs. And after that, I'll focus on how to take into account reduced mobility users in the evacuation facilities. And finally, I'll go through support and actions. Whether or not it's the result of an accident, the consequences of a vehicle fire in a road tunnel can assume catastrophic proportions in terms of human lives lost. In 1999, the fire in the Mont Blanc tunnel had a severe impact on the public opinion, and it mobilized the attention of French public authorities on the question of safety in road tunnels. As a consequence, a certain number of texts have progressively specified the procedures as well as technical measures to be followed in tunnels longer than 300 meters. Those main safety measures in a road tunnel can be grouped into 5 categories. The first category is prevention by controlling traffic conditions. That is to say, measures which are traffic directed in terms of flow and in terms of composition. Second group is measures for assisting the evacuation of persons. I'll come back to that in a minute. Third category is provision of for ventilation and smoke extraction. These are specific equipment to manage the air and the smoke inside the tunnel in case of a fire. Fourth category is fire behavior of structures, which deals with specific civil engineering development inside a tunnel in case of a fire. And the fifth category is the organization of surveillance, intervention, and operation. These are various technical tasks which are performed by the tunnel operator and rescue services. So let's focus now on measures for assisting the evacuation of persons. The strategy for a fire in a road tunnel has to take into account road users outside the tunnel and road users inside the tunnel. So the first objective is not to expose users who would be upstream of the tunnel at the time of the fire. This means that we'll have to close the tunnel in case of a fire. And the second objective is to protect the users present in the tunnel from the smoke. So we'll have to control the fumes and to evacuate the people. Concerning the evacuation of people, we have a two-phase strategy divided into 2 successive steps. The first step is self-evacuation. Its objective is the protection of users when they're alone in the tunnel. And the second stage starts later because you need time for rescue services to get on the scene in the tunnel. Most of the time there are no first responders inside the tunnel. So the objective of the intervention of fire and rescue services will be to help save the people who are still in the tunnel when they arrive on the scene. This figure is the model of evacuation time of users in a road tunnel. If you consider a fire starting in a tunnel, let's say at time t0, after a certain time, which is the end of the yellow arrow here on the top dashed line, at that time you will have reached the limits of bearable conditions where the fumes will be toxic and the people won't be able to bear the fumes anymore. Sorry. In the first place, when the event occurs, you have to look at the green line here. There is a necessary time for detecting the event by the operator. Then there is a second time, which is for the operator to give the alarm. This means that in this gray zone, nothing or nearly nothing happens for users present in the tunnel. It is the matter of the tunnel operator to do his task and give the alarm to the users and rescue services. Then if you look at what happens with tunnel users on the blue bottom line here. Once the alarm has been set, there is a necessary time for perception, analysis, and interpretation about this event. After that, only after that, you get to a second period of time when the user prepares his response, his decision, and his action. And only then, at the end of this blue arrow here, the movement time starts within the tunnel. And at the end of this movement time, if you're lucky, you still have safety margin for extra users, maybe, who are slower to escape before the limits of bearable conditions are reached. So as you can see from this model, before making a decision of evacuating or not, there is an initial analysis time for the road user, because the users act according to elements or signals that they perceive, to the interpretation they make of these, and thus their representation of the situation at a given moment. This means that we'll have to take into account the following knowledge for improving the self-evacuation of users. We will have to deliver an alarm message which is suited to the situation. We will have also to provide information on dangers faced, also to give the instruction to quit the vehicle and to evacuate on foot towards emergency exits, and also to assist the users throughout the evacuation process until they return to their vehicles. This means that in terms of equipment, we can use such systems as an alarm siren to raise the alarm so that users understand that there's an important event happening in the tunnel. We'll also use dynamic chevrons to direct users towards the emergency exits. Also, we will use flashing lights on each side of the emergency door so that these doors are emphasized and the users understand this is the place they have to go. And in addition to these visual signs, we can use sound beacons, voice messages to emphasize the message we want to give them. And for users that are still in their cars, we may use radio messages which are broadcast within the cars, as well as stop lights, red lights inside the tunnel, and variable message signs explaining that there is a problem and emphasizing the effect of the stop light. So this is an illustration. Thank you for the sound. So first the sound, the siren, then the lights. And the message that says to the users that they have to get out from their car. Another illustration. This is after refurbishment of these exit doors. On the left photo, you have the view of an emergency door without flashing light, and on the right photo, you have the same exit with flashing lights. Okay. During the evacuation phase, while users move towards the exit, we use a combination of regulatory signaling, which is shown on this slide here. These are the green signs showing the location or direction of the exits. And these are associated with luminous markers on each side wall, which are constantly lit even when there's no fire. They are located at a height of 1 meter, spaced at about 10 meters from each other. And they are supposed to guide the users towards the exit. They should be visible even in case of smoke. And it's recommended that the additional systems that were already activated during the general alarm phase that I showed you just before should continue to function. These are photos illustrating the signs of the, illuminated signs corresponding to the emergency exit on the top left photo and on the bottom right photo. On the top left photo, you may also see the running man, which is painted on the wall, and that is running in the direction of the exit door. And when you have a rock side wall, like on the top right photo of the Lépine tunnel, you may use metal running man, which are affixed to the wall, and here they're painted in white to be better seen. On the bottom left photo, you may see green lights, which are emphasizing the presence of an exit door. These are lit permanently, and they come in addition to flashing lights, which are only activated in case of a fire. And these, as you can see, can still be seen in smoke conditions. Then we come to the evacuation case in emergency exit, and while the users are waiting for rescue services. It's essential that the support for self-evacuation does not stop once the user has quitted his vehicle and has passed through the exit door. It's really desirable to guide the user to the exit and as far as possible to provide him with information about the situation. On the left side here, you have the case of direct communications with the exterior. And on the right side of the screen, you have the case of the shelters, where it's necessary to explain to the users that the place is a safe place, and to provide them with instructions that they must remain in this place, and to explain that the rescue services will be arriving soon. Now, reduced mobility users, let's just start with a definition given by Directive 2001/85 of the EC. For this directive, passengers with reduced mobility mean all people who have difficulty when using public transport, such as disabled people, including people with sensory and intellectual impairments and wheelchair users, people with limb impairment, people of small stature, elderly people, pregnant women, people with children, including children seated in push chairs. In order to take these reduced mobility users into account in the evacuation facilities, we have to consider that emergency exits should be accessible, and also we should take all French accessibility regulations into account. This means that in the first place, we should have a lowered curb to access the emergency exit doors. On the left side here, you have the case of a new tunnel where it's easy to provide this lowered curb just in front of the exit door. And on the right side here, you have a photo of a refurbished tunnel where the lowered curb here is not just in front of the exit door. There's a small offset of 2 or 3 meters. Another provision is the vertical bar. The objective is to facilitate the opening of the emergency door at the entrance of a pressurized airlock, for instance, or pressurized exit. And on the photos here, you can see that a vertical bar has been installed on the left of the door, near the opening handle, in order to hold on. As you can see the man here, he holds on while the door is being pushed open. Then in the shelter, when it's not possible for PRM to evacuate themselves to the outside, it's desirable to provide behind the emergency door a specially arranged area where they can wait for the rescue services to look after them. This includes, for instance, a bench or a folding chair, or sufficient space so that the wheelchair does not block the passage. Now, a few words about supporting actions directed towards drivers or the general public. The Highway Code in France includes questions on tunnels, which have been actually introduced in the Highway Code exam since 2008. And also, a training course package has been developed for professional drivers since 2012 for the French version and 2013 for the English version. And in terms of education of the general public, at CETU we have published a series of short films since 2018, and more recently another one in 2023. The first short films were dealing with the situation of driving through a tunnel, the situation of having a breakdown in a tunnel, and the third one what to do in case of a fire. And more lately, we have produced a film on safety distances in tunnels. All these films are available on YouTube and Dailymotion. They're also available on CETU's website, and they have been provided to French tunnel operators and French motorways associations. So, as a final point, I suggest that we have a look at the short film, which is 1 minute long, on what happens in case of a fire in a tunnel. So the subtitles are in English, the voice is in French.
Imaginons que vous rouliez, que vous entriez dans un tunnel et que soudain, votre voiture prenne feu. Il faudra réagir très vite. Alors prenez 1 minute pour apprendre les gestes qui vous sauveront. Ça commence par toujours repérer les issues de secours. Si la sortie est proche, continuez à rouler. Mais si l'incendie gagne, garez-vous le plus à droite possible et allumez vos feux de détresse. Coupez le contact, enfilez votre gilet jaune et faites sortir tous vos passagers. Si un extincteur est accessible, utilisez-le. Les secours sont alertés, l'accès au tunnel est interdit et l'ordre d'évacuer est donné. Si vous êtes proche d'une sortie vers l'extérieur, allez-y, sinon dirigez-vous vers une issue de secours. Et ne retournez jamais vers votre voiture. Contactez l'opérateur, puis suivez les flèches vertes jusqu'au point de rassemblement. Grâce à votre sang-froid, personne n'a été blessé dans l'incendie. CETU, Centre d'études des tunnels.
Okay, so that's it for my presentation. Thank you very much for your attention.
Thank you very much, Hélène, for this very nice lecture. It's time to move to our last presentation. Arid, please. So maybe a few words to introduce you, Arid. I don't know if we've got the biography, or we'll try to remember of your history. We've been collaborating together actually for more than 10 years, I think, both as a Payark Road Tunnel Technical Committee and also as IT ecosystem members. And you were former, in charge of the road authority in Norway about tunnel safety officers? Yeah? Used to be. And now you are the CEO of your own consultant firm, company, yeah? And also the animator of, I think, the Norwegian tunnel cluster community. Yeah. And you will be talking now about some technology because it will be a look towards the future, talking about new digital tools to help to better operate our road tunnels. I have to sing a song.
Is the internet working? I hope it's working.
To tell a story.
Before, but okay.
The floor is yours, Arid.
Thank you so much. Yes, I have to say thank you for inviting me here at the Indian Road Tunnel Congress. And also thank the chairman for the nice words. And thank you for listening, gentlemen and ladies. I will speak about new digital approaches for safe operation of tunnels in the context of experience. As Eric Beautiful said, I have my background from the Norwegian road authorities. I've been the national tunnel manager in the road authorities for 7-8 years and have experienced some of the biggest fires we have had in Europe. Now later, I've become an expert advisor. So I'm running my own company, but I'm also the CEO for something called the Norwegian Tunneling Network. And this is our present occupation. I have experience from both the contractor side, the client side, and also the advisory side. So I've been sitting on all sides of the table, more or less, in these projects. I will give you a short introduction. I will also say what influenced the outcome of incidents. I will have a look into the traffic control centers, the heart of safe operations on road networks. I will say something about operational challenges on road network and recent experience. And for God's sake, start in early planning with the operation and maintenance issues. So that will also be emphasized. Followed up by something called RAMS. We will also look into standardization and also research, development and innovation and ITS impact on the future tunnel. As I said, I have some relevance. This is me on prime time television explaining the Norwegian people if the road tunnels are safe in Norway. And this is right after we had a catastrophic fire with no injuries actually, but it was a 400 megawatt fire in a long subsea tunnel. Long subsea tunnels will be my presentation tomorrow, so I will say more about that, but more about planning and construction of those, but also a little bit of operation and maintenance. So this is, of course, a matter of interest also for the public, because this is about the safety of the public. When it comes to IT COSUF, I will give a small promotion of this beautiful network. This is a committee within the International Tunneling Association, and it aims to being the center of excellence for worldwide exchange of information and know-how regarding safety and security of underground facilities. It's not only road, it's also all other underground constructions we are involved in. And it's a very nice way of meeting good professionals within this topic. So I highly recommend this for people from India. Very shortly about the Norwegian tunneling network. The reason I'm bringing this up is that this is a very good cooperation throughout the whole industry in Norway when we are going internationally and we are supporting other nations. And India is a very interesting market for us because we see a lot of similarities in what they are doing in India to what we are doing in Norway. So that means that we have both the universities and the research organization, advisory and consultancy companies, contractors and product and service suppliers with us in this work. I will say about Norway, our philosophy are our strength. Cost-effective design, construction and operation. We have a history in thinking cost-efficient development of infrastructure in a challenging and demanding nature and scattered population. So low traffic solutions is maybe our specialities, but also these kind of solutions in very harsh environment and in very demanding nature. We have done this road infrastructure developments for more than a century, and also within rail and hydropower we are really strong when it comes to tunnel and underground constructions. So we have experience with the largest, the longest, the deepest and most complex projects in the world when it comes to tunneling, and we plan to break all records in the coming years, including construction of the largest subsea tunnels in the world. So the picture you see here about the map, this is a Rogfast subsea tunnel that is under construction in this moment. It's 26.5 kilometers long. It's a twin tube and is 390 meters below sea level. And of course, there are some safety issues when you are doing that kind of projects. Cost-effective designs. Requirements that ensure the right level of investment. We have to remember, we have to have our investments also on other things, like the road outside the tunnel. That means that traffic density, characteristic of the tunnel, and a systematic evaluation of RAMS criteria and risk decides the design of a tunnel. That also include all the electric technical facilities and the digital approach. It is important to be able to invest in a cost-efficient road network in both city and rural areas that balance the investment on open road and tunnels, considering traffic safety and other risks in a systematic way. Very short, what influenced the outcome of an incident? We have to remember it's not only technology. It's very often we are talking about technologies, but it's also organizations and also individual human resources also involved in this. And everything have to cope together. So that means that we have to have a very good framework of regulations and processes and documentation that support this, all this attention. So, and also, of course, the commissioning and safety approval. And one of the best things that have happened for Europe is actually this EU directive that says that you actually need to have a safety approval for opening a tunnel. And that makes it much easier for the people that is concerned about the safety. An incident is is influenced by emergency preparedness and response, emergency and preparedness and response from the emergency services, not only the traffic control centers, but also the motorists and vehicles and the road tunnel itself. So imagine if you have a tunnel that is between two cities, connecting regions, you have a lot of motorists that is not familiar with the road. So they have a little bit other focus on what to do in a certain tunnel. But a tunnel in a local community will probably have some other issues again. And everything needs to be treated in these risk analysis, and especially when it comes to the quality part of this. I'm mentioning the traffic control centers because they are a very important part of everything is functioning well. In Norway, we have about 1,500 road tunnels. We have between 65 and 70 of these tunnels is longer than 4 kilometers. And the longest road tunnel we have today is 24 kilometers. And these are controlled by only 5 control centers. And we have to ensure a uniform and effective operation, and we manage to do that because we have a very high professionality when these have to cope with the whole region. They are training every day on live situations, and they are really up to date when it comes to this. But it's also a lot of other organizations involved, and you can see there here. But how do new experience influence the tunnel regulations? We had some severe large tunnel fires in 2011, 2013, 15, and 17, and we have had some afterwards there. For instance, in Gudvanga Tunnel, 67 people were caught in the smoke for 2 hours. What really happened there is a very good example of reliability, because we lost, before the incident, the communication on one of the zones in the tunnel. That means that the ventilation could not be controlled in that area. So when the fire happened and we have a predefined ventilation direction that is suitable for the fire department, suddenly we had some of the fans going the wrong direction. So the reliability on these systems are very important and sometimes forgotten. And when I investigated this in this specific tunnel, they had these failures about 1,500 times for each zone in a 3-year period. And then I asked, do we really have ventilation in that tunnel that is sufficient? This is something we need to pay attention to also. The other thing about that incident that was very interesting is that social media is probably the fastest measure when it comes to quick response. Because I was sitting on the beach in Nice, took up my iPad, started to read, and I saw it was a fire in the Gudvanga Tunnel. I called the traffic control center in Bergen. They didn't know. And very soon, pictures and videos and everything came up on social media. Of course, we have done a lot of things after that. And in general, we have done a lot when it comes to different kind of measures. But the most important part, and this was also said about from Helen, is how do we really respond when we are going to self-rescue. And what we experience, it takes 7 to 10 minutes before we have a smoke situation. That means that all these systems need to react and start before those 10 minutes. That means that we have to detect, notify, and evacuate very quickly. So focus on quick response and supporting the self-rescue principle is, of course, very important. Start in early planning. Operation and maintenance is an important prerequisite. What we have included now in the regulations in Norway is something called RAMS analysis. And this is something you do for the whole system, for the whole tunnel, but also on the individual system and so on. That says something about how you should prioritize, for instance, availability. If you have a subsea tunnel, as I described before, the Rogfast tunnel, you have about 4-hour drive around to get to where you would like to go. And in that case, availability is very important, and that means also that you have to install different kind of systems that make sure you can actually use the tunnel, even so one of the tubes is not working. And then you have to have additional safety measures to cope with that. For suddenly you are introducing a concept of bidirectional tunnel in that unidirectional tunnel and so on. So that is also very important. I will come into this tomorrow also as well. I will just mention also, to support this kind of development we need when it comes to develop new systems and so on. Please never specify your guidelines on products and so on. Specified is as a function-based standards. That is the recommendation, because then you will make sure that the industry actually is have a chance to respond and get to the contracts right away. And the standardization organizations around the world are experts on that, and it's a very big mistake to actually move into the area where you don't allow any innovation at all. When it comes to research, development, and innovation, focus on cost-effective designs, RAMs, and facilitate sustainable development. So what we are working with now is next generation 3D BIM modeling, industrial visualization, and VR, and digital twin. And the digital twin is very important when it comes to the final approval of the tunnel, the commissioning, because if you can start that process a little way before, you can actually have a much more cost-effective project. So I can also speak about that, but that's a completely different presentation. We have a very good example in an innovation project between the Public Road Administration and the industry. So this is the Public Road Administration together with the government, Innovation Norway and so on, making a competition of which company that can be part to make a new innovative way of making the evacuation easier in the tunnels. So they developed a system for fire incident detection for localization of fire and evacuation assistance system. The node can be supplied with cameras for video surveillance. The EVAC system supports sensor acquisition for fire, incident detection, and video surveillance. So this system uses 21st century technology innovations to deliver psychoacoustic direction in evacuation, public address messaging, and lighting effects in a very cost-effective way. And I have a short video about this, if internet is working as we hope. And maybe I should move to...
The EVAC solution consists of nodes throughout the length of the tunnel with a 25-meter distance between the nodes. The nodes are placed 2.7 meters above the road. The location is the result of acoustic calculations and temperature profile for fire detection. Each node consists of directional speakers, a microphone, and temperature sensors. In addition, the nodes can be equipped with LED lights and camera. The temperature sensors in each node are used for detection of the fire location. When a fire alarm is given, the road traffic center will initiate an evacuation. The evacuation will take place away from the fire and towards the tunnel portals or emergency exits if there are any. The evacuation principle is to use sound guidance to guide people in the right direction. SINTEF Research Institute has carried out tests in the Runehammer test tunnel in Åndalsnes, Norway, which shows that 91% of the test persons followed the correct direction. There was no significant difference with and without background noise. The SINTEF report has been published on the prestigious website Science Direct and can be studied in more detail there. Since a microphone is installed in each node, it is possible for the road traffic center to set up a two-way conversation with the individual nodes. This means that the operator can communicate directly with road users near a node. The system also functions as a conventional public address system where you can give regular voice messages to road users in the tunnel. The results of the development is so good that EVAC-zone has already been installed or ordered for the following projects. Nordeveien is delivered with reduced functionality, there only as a public address system. Flekkerøy Tunnel is delivered with full functionality, and Tromsø tunnels are ordered with full functionality. Ordered from Trafsys.
Oh. How do I switch here? Okay. Very shortly, if you allow me, Erik. Oh, thank you so much. What a great friend. When it comes to ITS systems, this is a great opportunity for the future, we think. So this is something we have investigated also in PARC, and we will continue to investigate. And what is an ITS system? An ITS system contains of technical installation that is giving and receiving information, technical installation that is controlled, but also application, SCADA system, single application that is processing information to either give support to the TCC and or controlling the technical installations directly. And we also have to remember new mobility concepts and vehicle types will affect tunnels, probably in a positive way. At least I think this will be something we can benefit from in the future. Okay. Yeah, it doesn't matter. Oh, okay. So imagine detect and start initial action as a response of a fire in a vehicle in the tunnel in an autonomous and cooperative car technology perspective. Well, if you have detectors in the vehicles that can give the traffic control center alarm of something is happening in a tunnel, heat detector in the vehicle that give the TCC a confirmation that the fire is starting, ventilation start automatically, manually, based on the position in the tunnel, an automated or manual message is sent out by the SCADA system to the vehicles, and automated or manual message is sent out by the SCADA system to the emergency services. So this is absolutely something that can be used, and we can react within these very few minutes we actually have when it comes to tunnel safety and especially fires. And the reason I mentioned is subsea tunnels, and example of one of the first places we are placing this technology in. Is the reason for this is 40% of the fires in the tunnels in Norway happens in these tunnels. And we have about 1,500 tunnels, 40 plus, between 40 and 45 tunnels are subsea tunnels, and a few more of those are tunnels with incline. And tunnels with incline have a very much higher probability when it comes to fire in tunnels. So thank you very much, and I hope you bear with me out of this presentation that came very, very at the end of the day. Thank you.
Thank you very much, Arild, for this overview about new technologies and what they can offer for the future. So I think I'm sure the three presentations very complementary. They raise a lot of questions. So it's time for a question. Yeah. Excuse me. Can you just introduce yourself?
Maybe
a mic.
A mic.
Hi, thank you. This is Dhairya Desai from AD Automators. I'm the managing director of that company, and we are also doing the same thing, in fact, on the SCADA part. So regarding that ITS system, I would like to know that you have shown the last slide regarding that. The motors or the cars will automatically send a signal to the control center regarding that. When you're talking about RAMs, is it necessary to communicate with the vehicle to the control system? Because in the RAMs, usually we are taking the data points on the hardware, right, if I'm not wrong?
When it comes to RAMs as a tool, this is something you are using in planning. And this is to consider all the effects that affect reliability, availability, maintenance, and safety.
Right.
Yeah. And how this will affect, suddenly you will probably have a system that is more reliable, because you will get signals for all the cars instead of from one single point in the tunnel, for instance. So this might also be something that will affect the reliability, for instance. But this is something we have to investigate in the future. So I will recommend more research on this, and not at least make sure that we are ahead of the whole ITS industry and give our support in this process when they are making these systems. Because to have open information from the vehicles, where you can actually use it in these kind of applications, would be helpful.
About vulnerability? About vulnerability? That signal can be vulnerable or anything?
Yeah, it can definitely be vulnerable as well, because it will be certainly vulnerable for our personal sphere. That suddenly you can, what happens with your vehicle is suddenly available for others. But it can be vulnerable also if you just depend on that system and somehow communication doesn't work.
True. Because communication problem we are facing also in lot many tunnels, like, when both the PLCs, like even though if it is a redundant PLCs, both goes into the halt mode because of certain configuration error or anything.
Yeah.
And that is causing actually the problem that entire tunnel would be blackout. Like no signals are from the tunnel coming to the tunnel control center. So that is exactly the hazard. But this concept is, I think that could be thinkable.
But it might be used just as additional information.
Yeah, true.
Just another help.
True.
Because in a lot of the tunnels in Norway, we are dependent on users calling us in and say there is an incident in the tunnel, and then they react. So we don't have all these systems.
So that would not be the single point of like information. That would be another sensing elements also which can be confirming that after receiving the information from there.
Yeah, and the best thing about this, we don't have any of the answers today because this is kind of the future technology.
Just a concept.
Yeah, we should definitely keep it open for that. Yes.
Thanks.
But this is
so
fun. Yeah.
Sorry. My name is Arthur Kabouya. I come from Belgium, and I am the working group leader of tunnel operation in PIARC. If I understand your question, is the problem of to get information and to have a reaction to the control center. What is important is for this information what safety function you want to ensure. Because if you are a safety function, you can have information come from other system to ensure the same functional function of safety. It's an example of if you want to put ventilation in to run ventilation, in case of fire, you need ID system, automatic incident detection system. But if you don't have automatic incident system, you can go to degraded mode and you use linear cable. Yes, that's why it's very, very important when you are design your tunnel to have approach of functional safety, and for each function of safety, you need to have a lot, to have a group of information what you need to provide that functional safety, and it's a kind of resilience, and for that kind of resilience, we are writing a good report this year about resilience. You can find a lot of information to solve that kind of problem. Thank you.
Thank you, Arthur. Maybe we have other questions about lighting or self-evacuation process, please.
My question is to Mr. Aril. Myself, Arvind Kumar Jain, Engineering Chief, UP PWD. If I'm correct, towards the end of your presentation, you mentioned that the subsea tunnels and the tunnels on the incline are more prone to fire. So why so? Are there any specific reasons for it? Subsea tunnels, as you said, that subsea tunnels and the tunnels on the incline, they are more prone to fire, catching the fire. Actually, that they are more vulnerable to catch the fire. So, what are the reasons for it?
Yeah.
That I want to.
The reasons for this is that you get a much higher, you get a much higher power to your brakes, so you might get heated brakes and so on. But this is not really a problem, because in most cases, statistically, in most cases, it's very easy to extinguish. And in many cases, we don't even get the reports on these fires because they are handling it themselves.
That is okay. But the incidence of fire is more in subsea tunnels and on the tunnels on the incline.
Yeah.
So what is the reason for it?
No, it's the same for tunnels that have incline, and that is including the subsea tunnels.
Yeah.
So it's in general all tunnels with incline, and what we also have seen is that if a vehicle have a weakness in the engine, and you suddenly go into this incline, you get really stress this machine, and you get the failure.
Okay.
And the presence of that failure and the liquid diesel or whatever under pressure, if that caught fire, suddenly you have a fire that is very not easy to extinguish at all. They will not manage it. And in these cases I've shown here, in most of those cases, that's what happened. And the reason for this is they are not able to extinguish it in the early phase. So they need a fire department, and when the fire department is arriving, it's too late, because that's more than 10 minutes, because these are tunnels quite a long way from people. So we are making these statistics every year, and we have about 2 tunnel fires a month in Norway, and 40% of them are in these with incline. So also on mountain tunnels and that kind of stuff. Yeah.
My question is to Pierre. My name is Pratap Patil. I'm from Forbes Marshall, Pune. So the topic which we introduced is lightning in the tunnel. So luminance as well as luminar. So in daytime and nighttime we use as a safety, but you enhance as an energy conservation. So how it will be energy saving, luminaire will be play a role. I just wanted to get more explanation on that.
Yeah, can you just repeat the last section?
The thing is, you are using the luminance at the outside the portal and illuminance inside the tunnel, right? So safety point of view, remove the black hole effect. And then one more sentence you've added as a energy saving point of view or energy conservation point of view of the lightning, to save the lightning of this. So how it will be energy saving point of view, lightning saving point of view, light saving point of view, electricity?
Yeah, the luminance meter is, as you indicated, installed outside the tunnel. This one will monitor the light level during the day and during the night. And the illuminance photometer are installed in different sections and will basically monitor the light level at different stages of the day, and will basically send the information to the brain of the system. And this one will basically confirm that I ask for such level of lighting. My illuminance photometer that are during the commissioning characterized and calibrated in different zones will confirm if we have the right lighting level. If the light are dirt due to accumulation of carbon monoxide and all this, the sensor that is typically less affected by those effect will inform the system, and then we will adjust the light level to compensate.
So the controlling unit will be the different. It will have an additional unit as a controlling to light. Is it different unit or it just gives the feedback to the?
Yeah, it's a feedback to the system.
Okay. Okay.
Yeah.
Fine. Thank you.
Last question on the. No? I've got one for Helen, making the link with what Arid said. Helen, what would you say that this new technology, but can they offer when we think about self-rescue process? Can they bring new possibilities? And what would you say? Which main messages would you like that we keep in mind using these new technologies?
I think they can bring useful information to the tunnel operator, for instance, in terms of number of passengers in the car or bigger vehicle like a coach. Or this is an important information to be provided to the rescue services to check if afterwards everyone is really in safe conditions. Another important information is on the type of motorization. For instance, we all know that there are new issues at the moment, and PARC is working on this with new energy carriers, and we believe that knowing which energy is powering the vehicles is an important information for operators, but of course for fire services as well. So there's quite a lot of useful information to be provided in the first place to the operator, who can then in turn provide it to the rescue services. And some of the information, as has been said before, can come in addition to information already provided by the tunnel equipment within the tunnel. So it may improve the quality of information.
Thank you very much. So now, Raoul, I think it's time to try to sum up a few key ideas. So I give you the floor.
Yeah, thank you, Eric. Thank you, Eric. From the presentations, it may be noted that there are two major hazards in tunnel operations. That is, one is crash and second is fire. So as regards crashes, I would like to inform three interesting facts. First is that crash rates in short tunnels is higher than the long tunnels. Second fact is that the crash rates in tunnels are lower than in open roadways, but more severe, especially when in case of fire. And third, the crash rates could be lower in tunnels in inner zone due to driver alertness, but they increases due to monotonous driving. So these crash rates can easily be tackled, as explained by Mr. Pierre Longton in his presentation on intelligent lighting control systems. Lighting can change the mood and keep the driver in a state of high alertness and reduce the monotony. So appropriate lighting systems are a prerequisite in case of any long tunnel. They have to be designed to the perfection, and before their designing and implementation, the driver behavior is to be studied adequately, keeping in view the social conditions prevailing in that particular area, or the road user habits needs to be duly considered. Second hazard, that is fire. Fire is the most dangerous hazard in a tunnel. Ms. Mongo has described the tunnel fire safety in a very simplified way, and that too for persons with disabilities. Fire in Mount Blanc Tunnel in 1999 has been a turning point in evolution of the fire safety norms in Europe, and which has subsequently been adopted across the globe. Appropriate and timely dissemination of information to the tunnel users in case of fire is very, very crucial. Early warning systems and evacuation routes must be clearly communicated to all road users inside the tunnel during a fire incident. But here lies a catch also. We are evolving, discussing some norms, but the irony is that individual countries create their own safety standards that mutually differ to a large extent. So there is a need to have semblance among the fire norms and the safety norms among all the countries, so that uniformly it can be implemented across the globe. Now the third presentation on new digital approach for safety operations of tunnels by Mr. R.D. Shovik. Here he presented the status of Norwegian tunneling in a wonderful fashion. This country has evolved a robust tunneling network commensurate with the requirement of mobility and the environment. Tunnel safety has to have a very good framework of regulations and their implementation, which Norway has exhibited to a large extent. His revelation that around 60 long tunnels are being controlled by only 5 control centers is an interesting fact. The effect of integration of control centers of various tunnels makes an interesting study itself. How it is acting, how it has economized the tunnel operations, and how it has influenced the decision making is also needs to be adequately studied. And such type of systems can also be planned in India. Mr. Arlid has rightly pointed out to evolve and adopt standardized specifications by all the stakeholders in tunneling industry. This will make the product competitive and reduce its prices especially for the low-income countries. In the end, I will urge the scientists, experts, the manufacturers, the entrepreneurs who are present here, they must consider the requirement of low and middle income countries while evolving and developing safety standards, appurtenances, the devices for tunnels. Thank you very much.
Well, now it's time to conclude. Thank you very much, Harold, for this very comprehensive summary. And I'd like also to thank our 3 lecturers for a variety of talks and covering different topics. 3 feedbacks from 3 countries, Canada, France, Norway. So with some issues related to safety equipment and the focus on lighting, very interesting. We've also links to sustainability issues, so important to keep in mind. We've also the topic about the safety evacuation and also accounting for the disabled people. As you said, it's not only people in wheelchairs, it's also old people. And so almost a lot of population that has to be accounted for. It's another pillar of the sustainability. It's a societal point of view. And thank you also for the overview and this aperture to a future. I mean, opening the mind, and if we have to look and to find new solutions using new technologies, and it's a very good thing. Just to conclude, I hope that the elements that you will keep in mind after this technical session that will be helpful when for those who are currently in charge of designing or building new tunnels, because I definitely think that these topics, these safety topics, operational topics, they have to be accounted for as early as we can do, I mean, in the new projects. So it's very important that the engineers, the designers, they have these expectations in mind when they design new tunnels. So thank you also now to the audience for the very fruitful discussions. I hope you enjoyed this technical session, and I wish you a very nice evening, and hopefully we meet tonight for the dinner and tomorrow. Thank you very much.
With discussions, questionnaires, and the conclusion of the seminar in hand, I thank every presenter today to explain every issue sharply and concisely. To thank which, I request Shri Arvind Kumar Jain, Vice President IRC, Engineer-in-Chief, PWD, Uttar Pradesh Government, to come ahead and felicitate our chair for the session, Mr. Eric Permart, our co-chair, Mr. Rahul Gupta, Chief Engineer, and also felicitate our fellow presenters, Mr. Pierre Longton, Ms. Helen Mongo, and our last presenter, Mr. Arnold Sowick. With this, we find ourselves at a conclusive end for the day. Having learned major issues regarding our agenda for the seminar and having found ourselves with many objectives and solutions for the same, we limit the day for further proceedings, giving ourselves a time to refresh, understand, and comprehend the gravity of everything discussed. I'm likely to remind every dignitary and direct them towards our cultural event that is to be held at the Vedanta Auditorium, 5th floor, and also remind that dinners will proceed after the cultural event at the same venue. I am also to remind everyone about the shuttle services which are now available for the Hotel Madhuban, Sarovar Premier, Lemon Tree, Red Fox, and Farfield by Marriott. I thank our honorable presenters to participate vividly and vividly exemplify the issues, and I extend our gratitude towards the chair and co-chair for maintaining the flow of the proceeding with their utmost skills, excellence, and experience for the same. We congratulate everyone for the conclusive day and request everyone to retire for the day and refresh themselves with cultural festivities planned ahead. Thank you, everyone.